This video is about multiplying fractions. I'd like to start with a model. So we're going to multiply 3/4 times 7/8. Another way to think about this is that multiplication sign is of. So we're also looking at 3/4 of 7/8. The easiest way to multiply it is with a unit rectangle. A unit rectangle is a rectangle, and I'm going to divide it up into parts. So I'm going to start with this fraction 7/8. I'm going to divide this into 8 equal sections. So there's half, there's fourths, there's eighths. I'm going to color in 7 of those because I'm only talking about 7/8. I color in all of the 7/8 of that rectangle. Now I want 3/4 of those. So in the opposite direction, I'm going to divide this rectangle into 4 parts. Shall I use a pencil? So there's half, there's my fourths. I want 3 of those. So I'm going to color all the way across 3/4 of this whole rectangle. Now my answer in this model is the part where the colors overlap, where there's 2 colors. So that means this part right here has 2 colors. So my answer, my numerator, will be all the parts that are colored in, 1, 2, 3, 4, 5, 6, 7 times 3 rows. So that's 21 parts colored in, 21, out of a total 4 times 8 is 32. So my answer is 21/32. Now looking at that, I can also see the algorithm, why the algorithm works, which is 3/4 times 7/8. And to get my answer, I simply multiply my numerators together and I multiply my denominators together. If I can simplify, I should do that. This cannot be simplified. Now, there's some special cases of multiplying fractions. For instance, I might have whole numbers mixed in with my fractions. So I might have something like 2 3/4 times 5 1/3. In this case, I need to change my mixed number to an improper fraction before I multiply. A common student error is to multiply the numerators and the denominators and then the whole numbers, but multiplication doesn't work that way with fractions. We want to change them to improper fractions first. So to do that, I look at this amount and I see that I have 2 wholes and then 3/4. In each of my wholes there are 4 4/4. So a quick and easy way to do this is to take my 4, multiply it by this number, and then add this number. All of that over 4. If I were to draw a picture of it, it would look like this. Here's my 2 wholes, both of them broken into 4 parts, plus 3 more parts. So the question is, how many fourths altogether? 4 times 2 is 8, plus 3 is 11 fourths. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 fourths. I need to change my 5 1/3. So 3 times 5 plus 1. over 3. 15 plus 1 is 16/3. If I were to draw a picture of that, it would look like this. 1, 2, 3, 4, 5. All of these divided into 3. Plus 1 more third. Altogether, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16/3. Now I can multiply. So my 2 3/4 is the same as 11/4 times 16 over 3. Now, I notice that 11 times 16 is a really big number. So I see that I have 16 over 4. In this case, I can take out a giant 1, and that's what I want to do. I want to factor out my giant 1, 4 over 4. I'm going to rewrite this so it makes sense, and then I'm going to come back and do it over the short way. So I'm going to rewrite it. This is 11 over 4 times 4 over 3. This is the same as 11 times 4 over, and I'm going to use commutative property. I'm going to change the order. 3 times 4. Here's my giant 1. I factor that out. I make it an easier problem. I have 11 times 4 is 44 over 3 times 1 is 3. So in the same way on this one, taking out this giant 1, 4 over 4, is also called factoring out. 4 goes into 4 one time. 4 goes into 16 4 times. 11 times 4 is 44. 1 times 3 is 3. Notice I get the same answer here. Now if I want to change this to a mixed number, I'm going to divide 44 by 3. 3 goes into 4 once. 3 goes into 14 4 times, with 2 left over. So I have 14 and 2 out of 3, 2/3. That's my answer. So I hope this was helpful. Let me know if you need more help with this. Thank you.